Today we are going to discuss the past paper questions, the topics which we have done up till now. And if I remind you, we have done the reactions or the topics like benzene. We have done, yes, methyl benzene. We have done reactions and preparations involving phenol. And we have also done phenylamine. Okay?
And so PDC is a separate topic from PDC?
Yeah, no, PDC is part of this. So, I'll write it if you want it. Here is the BDC. So this is what we have done up till now. And we are going to discuss the topics today, which are the questions which are from this part, right? So if you remember that benzene's reactions, it also includes the structure of benzene, okay? So starting from the structure of benzene, we moved on to the methyl benzene, phenol, phenylamine, and now BTC, right? So this is the part of the question which we have done. Okay, let's start. Benzene can be converted into nitrobenzene by a nitration reaction. State the reagent condition necessary to carry out this reaction. If you remember, so benzene, what was the conditions? Concentrated nitric acid was the reagent. Concentrated sulfuric acid was the catalyst, and 50 to 60 degrees Celsius was the temperature. Okay. Similarly, what type of reaction is this? Yes, this is a ESR, means electrophilic substitution reaction, when one of the hydrogen of the benzene is replaced by nitro or NO2. The reaction proceeds via two steps. Now he's talking about mechanism. So reaction proceeds via two steps. Benzene reacts with an electrophile. As you can see the positive charge, so I know it's an electrophile. So he's asking for the intermediate and then turns it to this. You remember what happens when electrophile goes to the benzene ring? What happens?
There is a half circle, then a plus.
No, initially where the electron pair comes in to attach this X positive. Electrophiles do not have the electron pairs.
From the double bond.
Yes, this electron pair. Yeah, because that actually tells you that this is the electron pair that is going to involve the attachment of X positive. Without this curly arrows, there is no mark given, okay? And now as you told me, the circle becomes half, and then this goes, yeah. Yes, so X is also here, H is also here. But we know immediately this electron pair goes inside, okay? And then turns into this, right?
So also an NO2 is given. So what about that?
So yeah, you can use it as X or you can use it as NO2, okay? Draw the structure of intermediate Y. We have drawn the structure of intermediate Y. Identify the cation X positive. X positive, the one that is going to go off. The hydrogen. Yeah, sorry. Identify the X positive. Yes, you are right. NO2 positive. And what about the Z? H positive. And write an equation to show how X positive is produced from the reagents. How this NO2 positive produced? Concentrated nitric acid reacted with concentrated sulfuric acid to form what? Positive plus HSO4 negative plus H2. Right? So this is all about the mechanism of nitration, the questions related to that. Say the reagent conditions needed to convert benzene into chlorobenzene, right? So what is the reagent condition?
Sir, and Cl with any group. Like
Benzene to chlorobenzene we have to. So we want the Cl to be there. So we have to react it with Cl2. anhydrous AlCl3 catalyst and darkness. No temperature, darkness. What about bromobenzene? We're going through the questions which we have done up till now.
BR2 and HBr.
Yes. So benzene to bromobenzene. So Br2. Yes. Anhydrous AlBr3 catalyst. No darkness needed in this case. Nitrobenzene. We just did concentrated nitric acid, concentrated sulfuric acid, and 50 to 60 degrees Celsius temperature. The nitration of benzene is two steps reaction that can be represented as this. Yeah, we just did it. Okay, you know what will be this one? Look, circle half, hydrogen there, and A positive is also there. Okay, and next step, this electron pair goes in, okay, and then it turns to. We'll verify the A positive. What is A positive? And the 2 positive. Draw the structure of intermediate B, we just did. Both benzene and ethene react with the bromine, but the mechanism and the type of products of two reactions are different, right? For example, look. So ethene reacts with the bromine. I hope you remember. This is addition reaction, which we did in AS. And when bromine reacts with the benzene, this is electrophilic substitution reaction. Okay. State the type of reaction undergone each of the reaction 1 and reaction 2. We just said that. Addition and electrophilic substitution. In each of the reaction 1 and 2, intermediate is a bromine containing cation. In each of the following boxes, draw the intermediate and use the curly arrows to show how it is converted into this, right? So in the reaction 1, if you remember, I'll just take you to the AS. It was like this. The ethene molecule, when the bromine comes in, it is polarized. As a result, this is partial positive, this is partial negative, and then this electron pair is the electron pair that is used to make a bond between carbon-carbon is now offered to the bromine. In order to accept the electron pair, this bond between two bromine breaks heterolytically. And the intermediate formed is like this. If you remember, one of the bromine is going to attach. Let's say here. Okay, and that the bromine is getting positive charge. So this is the electrophile, and this is the intermediate, right? Carbocation. When addition reaction takes place, similarly here, when substitution reaction taking place, you know what happens? Plus Br positive. So this electron pair of delocalized bi-electron cloud is used to attach this circle half positive. Here is the H and here is the Br. So these are the two intermediate, and both of them, you know, are positively charged. This is the positive and this is the positive.
So you got पहला step लिखा है मुझे इलेक्ट्रोफाइल Br पे लोन पे attach हो रहा है वो show करते हैं फिर वो next वाला step से.
No, we have to show the both how it is formed because he's asking. Look, what is he's asking? The bromine containing cation you have to show in each of the following. Draw the intermediate, use the curly arrows to show how it is converted into, right? And then the Br negative here uses this electron pair to attach here, and then this is the electron pair which is used to. And the product is, I'm showing the product, you don't need to show the product. Here is the Br, and here is the 1,2-dibromoethane. Okay, so what he's trying to say that you have to show all the curly arrows. Okay, next. When ethene and benzene differ in their reactions with bromine, explain briefly the benzene molecule is planar. You have to explain why benzene molecule is planar, right? Anyone? Can you tell me why the benzene molecule is planar? Why benzene molecule is planar?
So there has to be two hybrids, so they form double bond.
Okay. First thing, as each carbon in benzene is sp2 hybrid. Therefore,
they have like double bond and then linear kind of structure.
sp2 hybrid, so it's trigonal planar with bond angle of 120. So whenever they ask you why it is a planar, you have to tell the simple words. It's sp2 hybrid. And when they have sp2 hybrid, they have this shape, right? So hybridization determines the shape in this case, right? Then they ask you, why carbon-carbon bonds in benzene ring of the same length? You remember I told you when they had X-rays analysis, they were thinking one of them will be shorter and one of them will be longer. Out of 6 bonds in benzene, 3 one length and 3 other length. But all of them were the same length. Why? Yes, because of the delocalized pi electron cloud, right? So there is no double and there is no single bond, right? So there are pi electrons, they resonate, they are delocalized over the whole ring. That's why they're not like a double bond and they're not like a single bond. Okay? The pi bonds are delocalized over the whole benzene ring. Right? Okay, next. Okay, next. No single or double bond. Benzene can be nitrated by warming it with a mixture of concentrated sulfuric acid and nitric acid. By means of an equation, illustrate the initial role of sulfuric acid in this reaction.
There's no single or double bond inside the ring or?
Yeah, inside or outside, there's no double bonds. So what about this? Nitric acid react with sulfuric acid to form what? NO2 positive, HSO4 negative, and H2O. Name the type of the reaction, describe the mechanism for the nitration reaction, including the curly arrows showing the movement of electrons and all the charges. Type of the reaction?
Yes, sir.
Right, you have to write the full word ESR. This mechanism that you have to draw, I'm not going to draw, we have drawn it so many times. State the reagent condition needed to convert benzene into chlorobenzene. No, benzene to chlorobenzene.
Cl2.
AlCl3 and darkness.
Sir, ये आप worksheet द्वारा send कर देंगे?
Yeah, I did. I just did. Look at this. Yeah. This is methyl benzene. The methyl benzene, can you see what is happening to this and what is happening to this? It is reacting with the chlorine to give monochloromethyl benzene. It is reacting with the chlorine to give 4-chloromethyl benzene. So what do you suggest? The reaction 1 condition and reaction 2 condition. In one case, the reaction is taking place on the side chain, and in another case, it is taking place on the benzene ring. So what do you suggest? No, I think you told me the other way around. Yes, for the reaction 1, it should be darkness, anhydrous AlCl3 catalyst. And what about that? Ultraviolet light. Okay. And that reaction is free radical. He's not asking. Free radical substitution. This is what? ESR. So both cases, chlorine is the reactant, but the conditions make a difference. right? Okay, I think we have not done this yet. Have we done? No, we have not. The chlorobenzene. Okay, next. Look at this. Some aromatic polynitro compounds are used in perfumes as artificial musks. An example is bore musk. Draw the structural formula of hydrocarbon that can be nitrated in order to produce the bore musk. What is the compound's formula which is nitrated to give this product? What do you think?
Except the NO2, the rest of it.
Yes. So before nitration, you just take it as an alkyl benzene. So just with I'm not writing the nitro group, so this is the one. So then you add concentrated nitric acid, sulfuric acid, and heat. Okay. Next. Suggest the structural formula of the compound formed by reacting bore musk with the excess of tin with concentrated HCl. When this bore musk is treated with tin with concentrated HCl excess, what is the product? You remember the tin with concentrated HCl? It's a reducing agent. And it reduces what? Nitro, benzene to phenylamine. So all the nitros are reduced to give what? Phenylamine. So here it goes. Here it becomes NH2, it becomes NH2, and this also becomes NH2, right? So rest I can draw the skeletal formula like this, and then this. Okay, because the methyls, nothing happened to the methyls. Okay, the same methyl is here. I'm just showing the skeletal formula. Next. Chloroacetophenone was formerly the most widely used tear gas under this name. It was used in warfare and in the riots control. It can be synthesized from ethyl benzene through the following route. Suggest the reagent and condition for the reaction 1. Okay, if you look at the reaction 1 very closely, you see where the reaction is happening. One of the hydrogen of alkane or alkyl group has been substituted. So what type of reaction is this?
Chlorination.
Yes. What type of chlorination?
With UV light.
Yes, with the ultraviolet light. Okay. And this is free radical substitution. Okay. Next. Suggest the reagent condition for converting ethyl benzene into compound E. So ethyl benzene into compound E.
So here is
E. Here is E. So if I have a ethyl benzene, now let me draw it here. Here is the ethyl benzene. Yes, go ahead.
So we need darkness and
yes, we can see clearly there is electrophilic substitution reaction taking place. One of the hydrogen on this is replaced. So this is AlCl3, Cl2, and darkness. Draw the structure of the product obtained when heating ethyl benzene with KMnO4, right? So when you heat this compound with KMnO4, you remember it's an oxidation? Yes, the only product that is always formed, what is the length of carbon chain? It is benzoic acid.
Plus CO2.
Okay, plus CO2, plus H2O. But he's asking only the organic product. So organic product will be benzoic acid. The question is concerned with the organochlorine compound. State the condition needed to produce the two compounds A and B. Okay. Condition for the reaction 1. Yes, as you can see, it's again electrophilic substitution reaction. One of the hydrogen of the benzene ring is replaced with the Cl, so it's electrophilic substitution reaction. On the other hand, you see the one of the hydrogen on this is replaced with the Cl, so side chain free radical substitution, ultraviolet light and chlorine. Okay.
Yes.
Next, I'm skipping this part. We have just done it. Come here. Just this part. Now, uh, there is a problem with A2 organic. A2 organic is very much easy and straightforward. But the problem is that the examiners mix up the AS organic into this. Then at times we feel stuck. For example, in this case, look at this. If you look at this, so you reacted methyl benzene with concentrated nitric acid, sulfuric acid. So what the product we are expecting? Nitro? Yes, no, the one nitro, the methyl benzene in one nitro. And which it goes, carbon number 2 or 4, I can see the product and guess where it goes. Sorry?
So when it is 2, 4, 3, 4,
So that's for the phenol only. Here it goes to NO2. And then you can see the CH3 also turning into what? CH2Cl. So this is Cl2 with what?
so with
Ultraviolet light. Now, look at this closely. What happened in this reaction? This is not the A2, this is AS. What changed? Look, you have to just, when you are doing organic, just closely look at the change. The only one change is here, that CH2Cl turning into CH2Cl. So it's a reaction of haloalkane, which we did in AS. So for that matter, we need NaCN, ethanolic, and heat under reflux. Okay? Or KCN ethanolic and heat under reflux. Again, there is another reaction which involves the AS. Look, H3O positive is for the hydrolysis. You remember, this is acidic hydrolysis. And acidic hydrolysis of nitrile always takes place and it becomes carboxylic acid. So I'm just going to change CN into COOH. And then here is NO2. So I hope you recall. Now it was CN turning into COOH. This is a hydrolysis of nitriles to get the carboxylic acid. Now what happened to the last part? This NO2 turning into what? NH2. This again we come to the A2 now. What is this? So what is this? Tin with concentrated HCl. And this is called the reduction of nitrobenzene to prepare phenylamine. Right, next. Yes, again. Here it is. Predict the products of the following reaction and draw their structures in the boxes provided. Note that the molecular formula of the final product is given in each case. So you have to think about this as well. Okay, now for the first one, what do you think?
So it will occur in side chain.
Yes, the chlorine, when sunlight, side chain, there are two methyls, here and here. So when the side reaction happens, one of the hydrogen is replaced. Let's say it becomes CH2Cl. At this moment, I don't know that what happened to this CH3. Is there any replacement of hydrogen with the chlorine here or no? So I'm going to just avoid it here because this will tell me the later, because the molecular formula is already given. Okay, so maybe both sides hide one of chlorine is maybe CH2Cl like this, right? Okay, let's see. Now NaOH aqueous is heated. When NaOH aqueous is heated, it is again ES reaction where the halogen is replaced by a nucleophile OH. So it will become what? This CH2OH. Okay. Now CH2Cl remains as now this point also told me and indicated me there is only one oxygen on the products, the molecular formula, which shows that no, the both chlorines were not replaced probably. Okay, it was still CH3. All right, so that's why I removed chlorine from there. So it is still CH3. But we have to justify this formula. Let's do it. For example, look, how many carbon? 1, 2, 3, 4, 5, 6, and then 7. Okay? And then 8. 8 carbon we needed. Okay, hydrogen. 1, 2, 3. 3 and 3, 6. The 7, 8, 9, 10. There is no hydrogens on these two carbons where the substitution has taken place. So that's 10 and 1 oxygen. Okay, we justified the molecular
So
formula.
we'll mention HCl in the
No, no, no. Only the organic products. What about this? Cl2 plus AlCl3.
So this is
darkness.
Darkness with darkness.
So
replace an H with the Cl.
Yes, so let's say we replace it here. Okay. Now what next? Concentrated nitric acid and sulfuric acid.
So N will be replacing one H.
Yes, HCl and then another. Okay. So I hope this formula completes. Yeah, 6, 7, 8 carbon, nitrogen, 2 oxygen, 1 chlorine. So yes, this formula is justified. What about this? The last part. You see, this is methyl, this is methyl. When you KMNO4 alkaline and followed by an acid, yes. So this turns into a benzoic acid. Now, I don't know both of them are oxidized or one of them. This can give me a hint if I look at the molecular formula. How many oxygen I can see? 4. 4. So it means here is oxidized and this one is also oxidized. Then it could only become, or no, but again, yeah, I think not both of them are oxidized. Look, now it reacts with CH3OH. CH3OH is an alcohol, and when acid react with alcohol, what is formed? Ester. So I have to replace this like this. So here it is COOCH3, and again COOCH3. Now we have to justify the formula. 4 oxygens, yes. How many carbons? 6, 7, 8, 9, 10. Yes, 10. Okay, and so 10 hydrogen.
Ester alcohol plus?
Alcohol plus carboxylic acid, they form ester. Here it is. The following chart shows some reactions of ethyl benzene and the compounds produced from it. Right? Now, look at this. Now, in every case, you have to tell me the reagent condition. Just forget about the question. Let's remake the question. Okay, for the first one, Aries, what is happening in the first one?
Free radical substitution.
No, yeah, it is a free radical substitution. Here is the carbon, here is the carbon, here is CH3, here is CH2, and one of the hydrogen of carbon is replaced. So it is free radical. What do you need then? Ultraviolet light. What is your name?
Nice.
Wes. What is happening in reaction number 2?
So Br is being attached, so bromination will come.
Yes. So
Br and it's AlBr.
bromination on the benzene ring. So Br2 and AlBr3. Number 3, I'll explain why, because it's again a yes reaction. You remember in AS we studied if there is a haloalkane, there is a one carbon having Cl and there is a here carbon having H. This H and Cl, they eliminate and a double bond formed between them, alkenes. And you remember what we used to have? NaOH, alcoholic, or KOH, alcoholic. Okay? This was elimination reaction, right? Heat and reflux. Number 4, look at the number 4. Anyone from Zoom? I need your contributions as well, please. Ayla, can you tell me the number 4? Ayla, are you there?
Ji, sir.
Okay, what is happening in number 4? Can you please tell me, look at this closely, where the change is happening and then how this change happened?
Sir, substitution क्यों NO2 लग रहा है तो मतलब concentrated HNO3 के साथ react किया होगा.
Perfect. Concentrated HNO3, concentrated H2SO4, and 50 to 60. Okay, number 5. Look at the number 5, bacho. Koi aur other than Ayla from Zoom, I need your contribution. What is happening in this? If you see closely, ethyl benzenes. Ethyl part is oxidized to form benzoic acid. So, Aries, what happened? KMNO4, the alkaline KMNO4 followed by NaOH, alkaline KMNO4 followed by acid. Okay, so it's it's an oxidation. Okay,
So any acid or any specific?
any acid. Ayla, number 6. What is happening in number 6? Ayla, are you there?
Sir, and Gigi.
Nitro turning into NH2. Ayla, we can't hear you, so we are moving on. We'll come back to you.
BD is being formed, so.
No, it's not BDC, unfortunately. It's phenylamine.
Also the.
10 with concentrated HCl.
You asking for 6 hours.
Ayla, I hope you're not breaking again. Can you speak so we can see your voice? Because it was breaking previously.
Sir, can you hear me?
Yes, now we can hear you loudly and clearly. Now, can you tell us now what about the 7?
Sir, ये कल वाली class I wasn't here for yesterday's reactions. ऊपर वाला
Yes.
आता था.
Yeah, if you missed the class, so you should go and watch this on the same day, okay, on YouTube. So we can connect in the next class. Okay, Reese, what do you think about this? Please do it today, okay? So NH2 turning into N2Cl.
BDC.
Right, BDC. Yes. So what we need to become a BDC?
For it, we need
NaNO2 plus HCl. I'll stay back after class. I need to speak. So NaNO2 plus HCl and 0 to 5 degree.
Don't we need any OH for neutralization of acid?
Yes, and the solvent used is NaOH aqueous. Now, what about the last step? The BDC is reacting with here. It's a kind of phenol. I told you what they do. They replace the phenol's OH. Yesterday, I think I explained it. The phenol's OH with Na, but it won't lose the phenol's properties. They are still there. Okay? So, phenol, when reacts with BDC, what is formed?
It's
A compound formed named as what? Azodie. Okay, and what was the principle for the azodie? Carbon number 2 or carbon number 4 of the phenol or phenylamine.
double bond and
Yes. So here it is. ONA, and here at carbon number 4, we are going to attach
and double bond and then
N double bond N, and then there is, I'm going to draw it in this way, benzene ring. And what is the benzene ring for the next? Here. Okay.
So what's the next line from? So benzene के बाद क्यों line दिखाइए?
Okay. Which one?
Last line.
Here it is. Look on the top. There was a ethyl group attached already with BDC. So I just copied it here. Okay. So here it is. This is the azodie that is formed. Okay. Next. Here it is. Now, he's asking us to show the sodium metal reaction with these compounds. I'm going to slightly change the question here. I hope you understand. The first compound is what? Phenol. The second compound is benzoic acid, which is a carboxylic acid. And the third one is, it's an alcohol, which is cyclohexanol, the secondary alcohol. Sodium metal. The metal, sodium metal react with all three. With phenol, with the carboxylic acid, with the OH. And when they react with the phenol, for example, they form like this. I changed the question a bit. plus H2. When they react with carboxylic acid, the sodium metal, yes, they do react. COONA plus H2. Okay, and then they react with cyclohexanol and ONA plus H2. Okay, now coming to the potassium hydroxide. Potassium hydroxide is an alkali. Alkalis react with the phenol? Yes, they do, to form again sodium phenoxide along with water, not hydrogen. But potassium dioxide, does it react with the carboxylic acid? Yes, to form again COONA, the salt of carboxylic acid benzoate, plus
Sir?
water, plus, yes.
सर COOK पॉजिटिव नहीं आएगा
Yeah,
KOH है
COK positive, sorry. And what about the last step? No reaction. The alkalis do not react with alcohols. The last part, sodium carbonate. The carbonates do not react even with the phenols. Yes, they do react with the carboxylic acids to form COONA and carbon dioxide and water, but there is no reaction again with the alcohol, the carbonates, right? So phenols do react with alkalis, but don't react with the carbonates. Okay, now next.
So is there any specific reason for that?
No, there is a reason, we'll discuss it. We have that reason in syllabus. Okay, next. What he's asking to step 1. He's asking us, okay, I'm going to put the question right here. What is the reagent and conditions needed for this step? Can anybody identify what is happening here? You see one of the hydrogen of the phenol at number 4 is substituted with an alkyl group. So it's alkylation. For the alkylation, you need what? Look, this CH3, this CH3, this CH3. So what it should be attached with Cl. Okay, because then this Cl and this H, they combine to make HCl, and this alkyl group is haloalkane actually we needed, and the respective haloalkane. Can you tell me what happened in the step 1, the reagent and conditions? In this case, sorry, AlCl3 was the catalyst. What happened in this reagent?
So it has formed a cyclohexane.
Sorry?
So the benzene ring is moved, so it's a cyclohexane some kind like that. So addition reaction?
Yes, it is 3H2 and nickel catalyst and heat. Okay. What about the last part? Esterification. And you need what type of carboxylic acid? It's an alcohol. What type of carboxylic acid we need? How many carbon atoms should be there? 2 carbon atoms. So it is either ethanoic acid or, okay, you can use acyl chloride as well. But here we are going to stop. We'll continue this in the next class. Tomorrow is the test, okay? And then day after tomorrow. Test is in the same class, okay? Thank you.
Chapter.